In the first video of this series, I looked at the science behind anthropogenic climate change, the idea that man-made carbon gases are responsible for global warming. 70 years ago, the view that carbon dioxide could affect the global climate was held by only a tiny minority of climate scientists. Many assumed that there would be some sort of self-regulating mechanism that would put things back into balance. Then there was the scientifically valid view that water vapor also traps radiation and warms up the Earth, and it's far more abundant in the atmosphere than carbon dioxide. But research in the 1940s changed all that. Guy Stewart Callender, a British engineer, showed that radiation absorption is not even. Water vapor absorbs radiation mainly in the 18 to 30 micrometer band and allows most of the rest to escape into space. In effect, these absorption gaps act like cooling vents. But carbon dioxide absorbs radiation in a different range, 8 to 18 micrometers. So Callender concluded that carbon dioxide mops up this escaping radiation, effectively acting as a plug to these cooling vents. Over the next few decades, objections to the idea of anthropogenic climate change were gradually eroded as more and more evidence emerged in support of it. Today, by almost any measure, the overwhelming majority of climate scientists accept not only that the Earth is warming, but that man-made carbon gases are responsible. In 2004, the magazine Science published a study by Naomi Oreskes looking at the degree of consensus. A search of scientific papers over the previous 10 years showed that all of those commenting or dealing with recent global warming, nearly 700 papers, explicitly endorsed the view that man-made gases are responsible. This survey is sometimes used to suggest that there are no papers disputing anthropogenic climate change and no alternative hypotheses. As we'll see, that's simply not the case. The survey results were obtained by doing a search for the words global climate change in scientific abstracts, so the results can't be regarded as 100% accurate. But they do give an indication of the overwhelming consensus supporting anthropogenic climate change. Oreskes also found that all major scientific bodies in the United States agreed that man-made gases are responsible for recent climate change. But although they're few in number, there are scientific papers supporting alternative hypotheses. Far from ignoring them, climate scientists are very familiar with them. The alternatives can be broken down into two basic ideas. Firstly, the proposal that increased output from the sun is driving climate change, a phenomenon known as solar forcing. Secondly, the proposal that cloud cover is affecting global temperatures. But first things first, nearly all climate scientists agree that the Earth's climate warms and cools in concert with the varying energy output from the sun. But the crucial question is whether that's the cause of the recent rise in global temperatures, basically over the last 40 or 50 years. 27 years ago, a paper was published with very strong evidence for exactly that. Egil Friis Christensen and Knud Lassen of the Danish Meteorological Institute looked at the pattern of solar activity over the last 250 years, and it matched almost perfectly with global temperature changes. But closer examination of the data revealed a flaw. To get their graph, Friis Christensen and Lassen had to filter the data. That basically means smoothing it out to account for background variation and local anomalies. This is standard practice, and they did that for most of the graph. But they didn't do it for the most recent part of the graph because the data needed to do it wasn't available at the time of publication. When it did become available, the graph showed a very different story. A very good correlation between global temperatures and solar output over most of the last 250 years, but not the very period that covers a dramatic rise in global temperatures. While global temperatures have been rising, solar activity has remained more or less static. Since the 1991 paper, a number of other research papers have been written, and nearly all confirmed what the revised Friis Christensen-Lassen graph showed. Solar activity explains most of the temperature changes over the last few hundred years, but not the recent period of rising global temperatures. But there's one more thing to check before discounting solar forcing as an option. All the historical data measuring the amount of solar energy falling on the Earth are derived by secondary methods. Sunspot counts, levels of carbon-14 and beryllium-10, for example. To get a measure of the sun's exact output, you have to go into space, away from all the meteorological clutter on Earth. So in the early 2000s, several researchers looked at the satellite data, which measures something called the TSI, total solar irradiance. But there's a problem. The main satellite series they depend on for their data is called ACRIM. The first ACRIM satellite, ACRIM-1, was in orbit from 1980 to 1989, when it was due to be replaced by ACRIM-2. But then the Challenger disaster happened, and ACRIM-2 didn't get launched for another 2 years. So there's a gap in the data, and exactly where the gap occurs, there's an apparent jump in the TSI. Richard Wilson of Columbia University, who helped devise the ACRIM equipment, made up for the gap by looking at data from another satellite, which confirmed the increase. Wilson derived a small increase of total solar irradiance of 0.05% per decade. But Judith Lean of the Naval Research Laboratory in Washington, using data from another satellite, found no increase in solar output, and other researchers confirmed that with measurements of ultraviolet radiation and sunspot counts. A third satellite even showed a decrease in TSI during what's become known as the ACRIM gap. But most climatologists say even if the ACRIM increase is real, it's too small to be significant, about the same order of variation we get in a typical 11-year solar cycle. This was also the conclusion of a review in the magazine Nature, which looked at all the varying data. The bottom line on solar forcing is that a lot of studies have been done, and this is far from an issue that's being ignored. Output from the sun is an important factor driving the Earth's climate. But climate scientists say that although there have been fluctuations, there's been no significant increase in solar output over the last 40 years. Solar forcing simply doesn't explain the recent dramatic rise in global temperatures. So what about the other objection to anthropogenic climate change, focusing on cloud formation? This can be divided into two basic hypotheses. The first suggests that cosmic rays seed clouds. When solar activity increases, particles from the sun keep these cosmic rays away from the Earth, and that reduces cloud cover. With less cloud to reflect sunlight, the Earth warms up. The idea was proposed in 1997 by Friis Christensen and Henrik Svensmark. They backed up their hypothesis with satellite data showing a correlation between low atmosphere cloud cover and the intensity of cosmic rays arriving at the Earth between 1980 and 1995. It's an interesting idea and one that's been seriously looked at by a number of climate scientists, but only a few support it. The most obvious problem is that the hypothesis once again hinges on increased solar output over the last 40 years, and climate scientists say that hasn't been happening. If that's the case, why the apparent correlation? Two researchers writing in the journal Astronomy and Geophysics studied this further and discovered that the correlation in fact breaks down after 1991. And any correlation that does exist may be difficult to pin down because of the age-old problem of cause and effect. The second idea on cloud cover comes from Richard Linson of the Department of Meteorology at MIT. He postulates that warmer tropical oceans result in fewer high-altitude cirrus clouds. Fewer clouds mean more infrared radiation can escape into space, cooling the Earth down. In other words, the Earth has a self-regulating mechanism. Linson calls this the infrared iris hypothesis. Before I look at this, let me clear something up. Linson says fewer clouds cool the Earth down because clouds trap heat. Friis Christensen and Svensmark argue that fewer clouds warm the Earth up because clouds reflect sunlight. Well, this whole area is a bit tricky. Clouds do both. When planes were grounded across the United States following the 9/11 attacks in 2001, American skies were suddenly clear of contrails for 3 days. Contrails form high-altitude clouds, so this was a unique opportunity to study their effect. Scientists from the University of Wisconsin and Penn State analyzed temperatures for the 3 days before and after 9/11. They found that daytime temperatures rose by a little less than 1 degree thanks to the disappearance of the contrails that no longer blocked the sun. But nighttime temperatures fell by an equal amount because the contrail cloud cover was no longer there to act as a blanket, preventing the escape of infrared radiation into space. Bing Lin, an atmospheric research scientist at NASA, found that instead of cooling the Earth, as Linson had predicted, the effect of fewer cirrus clouds in the tropics is to very slightly warm it. Lin also couldn't replicate Linson's results on increased cirrus cloud formation, and he soon found out why. Linson had chosen to base his model around Indonesia, which has the warmest pool of water on the planet. So it's not typical of the tropics. Lin found that over the tropics as a whole, the increase in cirrus cloud cover from warmer temperatures is much less than Linson had predicted. There are other factors affecting the Earth's climate, most notably volcanic eruptions, but climate scientists agree that this isn't a significant factor in the current period of global warming. This and the previous video covered the science of global warming and the scientific debate among experts. In the next video, we'll descend into something far easier to unravel, the urban myth swamp, as we try to sort out fact from fiction and track misinformation back to its source.